Good morning to one and all. This is the third class in CAM, what we are doing. In this class also we'll discuss how to draw the profile of a CAM in case of a roller follower. In the last class we have seen for knife edged follower. In this class we will see for a roller follower. This is the statement of problem. A cam with a minimum radius of 25 mm rotating clockwise at a uniform speed is to be designed to give a roller follower at the end of a wall rod the motion described as follows. 1. To raise the wall through 50 mm during 120-degree rotation of the cam. Second, to keep the wall fully raised during next 30 degrees. 3. To lower the wall during next 60 degree. Fourth is to keep the wall closed during rest of the revolution, that is 150 degrees. The diameter of roller is 20 mm and the diameter of camshaft is 25 mm. Draw the profile of the cam when the line of stroke of follower passes through the axis of camshaft. The displacement of the wall while being raised and lowered is to take place with simple harmonic motion, that is SHM. So this is the statement of problem. In this problem you understand that the outstroke, the lift of follower is for 120 degrees. Then after there is a dwell, it will remain at the lifted position for next 30 degree of cam rotation. Then for next 60 degrees the follower will return back to the base circle. Then again at base circle there is dwell for remaining 150 degrees of cam rotation. Here in this problem you can see the minimum radius of cam is 25 mm and along with that we have a roller. We have a roller which is having 20 millimeter radius, which is running along with the cam. Then maximum lift of follower is for 50 mm. The diameter of camshaft is 25 mm, what is given in the statement of problem, but this is a extra data, will not this is not essential to solve the problem, but anyway we'll draw this circle. Then cam rotation is in the clockwise direction. So as we have discussed in the previous class, we will draw the profile in the anti-clockwise direction. First, in this problem, we will draw the displacement diagram. I have drawn the x and y axis. Again along x axis, I have drawn the angle of rotation of cam. First 120 degrees is the wall rising. Then next 30 degrees is dwell. Again next 60 degrees is return stroke and again dwell for remaining 150 degrees. Now this 120 degrees what you can do is you can draw it 6 centimeters. From here to here you draw 6 centimeters. 120 degrees is 6 centimeter, so this will be 60 degrees will be 3 centimeters and this is 1.5 centimeter. So draw here 6 centimeters. After that you mark a point at 1.5 centimeters, then you mark a point at 3 centimeters. Now remaining any much length is there, you can either draw a straight line or you can draw a zigzag line here and you can draw this rectangle. The height of this displacement diagram is 50 mm as 50 mm is the maximum lift of the follower. Next, in this 6 centimeters, whatever we have given, we will make 6 divisions. So every 1 centimeter you make a division and mark it as 1, 2, 3, 4, 5 and 6. Similarly, this 3 centimeter also you divide into 6 divisions. So mark at half, every half centimeter, half, 1, 1.5, 2, 2.5, like that, and mark these points as 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Next, these lines, these markings you extend till the top of this displacement diagram, and this line is drawn at distance of 50 mm. Measure here 50 mm and complete this rectangle. Now extend all these lines till the top line. Since the motion of follower is with SHM, the construction of displacement diagram with SHM is like this. What we will do is we will mark the center of this line. As it is 50 mm, I will mark a point at 25 mm, which is center, and taking that as center, and your rounder taking radius of 25 mm. So this center is the center of the semicircle, and taking radius of 25 mm, that is starting from here to end here, I will draw a semicircle. Now the circumference of this semicircle we have divided into 6 number of equal parts. That is as much we have done here. 6 parts here, 6 parts on the circumference of this semicircle. So what we will do is we will take the same rounder which is having the same radius of 25 mm. What semicircle we have drawn, same will take, and will keep the rounder here with radius of 25 mm and cut an arc here. Then I'll keep the rounder here, I'll cut one more arc here. Next I will keep it here. I'll keep the rounder here, and I will make this, I will draw this arc, and again I will keep it here and I will draw this arc. So we have cut this into 6 parts, that is 1, 2, 3, 4, 5 and 6. So you can see here all these points, as I have told you, are marked A, B, C, D, E, F, G, H. J is wherever this and this are intersecting. K is wherever this line and this are intersecting. L is wherever this line and 3 dash are intersecting is L, M, N and P. So joining all these points, we will draw a smooth curve A, B, C, D, joining all these points. So this is the displacement diagram for the follower. Now next we will draw the cam profile. Always we need the displacement diagram to draw the cam profile, as I have already discussed with you. Now first we will draw a base circle which is having radius of 25 mm. Take the center and draw a circle which is having a radius of 25 mm. This is base circle. Now when you draw this circle, you please see that there is sufficient space on the left hand side, and also there is some space above. You can draw this circle at the end of page, only a little bit space here is sufficient, but you need to have sufficient space on this side, some space below also, and some space above. Now here above the circle, since the follower is having a roller follower, exactly you draw a vertical line from the center of the circle for the follower. Now here exactly touching this circle, we have to draw one more circle which is the roller circle, and the diameter of this is 20 mm. So what you do is, above this circle you measure 10 mm. There will get the center of this circle. So taking that point as center, draw this circle having radius of 10 mm. So we'll get roller of 20 mm diameter exactly over this circle. Okay, so this roller is attached to the follower. Now we have to draw these two lines of the follower. There is no exact dimension that you have to take between these two lines. You can draw them a bit closer also, then it will be like this, and then draw a zigzag line. Even height of that you can draw it conveniently, there is no dimension for that. So completing that, you can draw this roller. Now center of the roller is marked as point A here. Next we'll draw these two more circle passing through the center of this circle, passing through, take using rounder, taking this as center and radius up till the center point of this, I will draw this circle, which is now called as prime circle. Now all the distances of the follower will measure from prime circle only. Now this is a camshaft. It is given that the diameter of camshaft is 25 mm. So radius is 12.5 mm. Taking this as center and radius as 12.5 mm, we have drawn this camshaft. Anyway, we are not using this circle for drawing the cam profile, as dimension is given. Anyway, we have drawn it. So this is the prime circle what is drawn through the center of roller. Now in the next step, the rise angle of 120 degree is there. So you keep your protractor here. From this line you measure an angle of 120 degrees in the counterclockwise direction and draw this line, and from this line again you measure 30 degrees in the counterclockwise direction and draw this line, and again from this line you measure 60 degrees for the return stroke, and draw this line. So we have drawn three lines, one at 120 degrees, second at 30 degree and third at 60 degree. This 120 degree whatever is there, we have to divide into 6 divisions, as we have done 6 divisions here also. We have to divide into 6 divisions. So you keep your protractor here, and then at every 20 degrees you make one mark. 20 degree here, 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 20 degree here. Do the markings and draw line through every division. Even you can draw this a bit longer. These are all thin lines. You can draw long lines, no limit on the length of them. So every 20 degrees we have drawn a line. Now this 60 degree whatever is there, we have to again divide it into six divisions. So again keep your protractor here, and every 10 degrees you mark. 10 degrees you mark, 10 degrees, 10, 10, 10, 10. So we'll divide this 60 degrees into 6 divisions. So we have 6 more lines, 1, 2, 3, 4. You can draw these lines longer. These are thin lines, longer line also if you draw. Even if you draw some extra lines, it is not a problem, but you should not draw less lines, that's all. Now all these lines, wherever they are intersecting the prime circle, please remember we'll draw all the marking from prime circle. Say this first line intersecting the prime circle here, this I will mark as point 1. This line is intersecting the prime circle here, point 2. This is 3, this point is 4, this point is 5, this point is 6. So I have done all marking. This is 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and this is 6 dash. Now this is the very important step in this profile. What we will do is same like what we have done in the previous problem. From 1 we have to mark this arc at distance of 1b. See here, 1b is the distance here in this displacement diagram. So from 1, the distance of b you take with rounder and keep your rounder at 1 and draw a small arc to cut this first line. So that is point B. A is at 0 displacement, so A will remain at the center of this follower wherever it is. Similarly, 2 to C you measure with rounder. From point 2 you draw an arc which is C. From 3 to D you measure. From 3 from 3 you measure, keep your rounder here at 3 and draw the arc D. Then 4E, take the length 4E with your rounder, then keep your rounder here and draw this arc at E. So this all you are doing with your rounder. 5 to E, 5 to E you measure, draw that arc here. 6 to G you measure, draw that arc here. Similarly, you have to measure 0 dash and H. So keep your rounder here at 0 dash and cut H. Similarly, you will cut J, K, L. Say L is where? L is 3 dash and L. So from 3 dash you cut L, keeping the rounder here. Similarly, you cut M, N, and P has come on the baseline. So P will be exactly on this prime circle. Now what we have to do is, as the roller diameter is 20 mm, having this point, these all points, that is point B, B I have marked B, C, D, E, having B as center and radius as 10 mm, I have to draw this circle. So this circle is drawn, roller circle, having diameter of 20 mm and having point B as center. So keep B as center, with your rounder take radius of 10 mm and complete this circle. Take C as circle, radius as 10 mm, complete this circle. D as center, radius of 10 mm, complete this circle. So at all these points, E, F, G, even H, J, K, L, at all these points you have to draw a circle which is having a radius of 10 mm or diameter of 20 mm with your rounder properly. And one more thing, if it is difficult to draw a circle of 10 mm radius using the rounder, you can make use of Pro Circle. In Pro Circle there are many circles, which is a circular protractor if you have seen. So you can take that, in that many circles are there, you identify circle with 10 mm radius there, you can keep it here, exactly, so that the center matches with this point and draw the circle. Center matches with this point, draw a circle. Center matches with this point, draw a circle. So you can see we have all the circles of the roller in position. Now the cam profile we have to draw such that it starts at this point and goes tangential. It should go tangential to this all circles. That it should not, it should be just drawn touching. It should be just drawn touching all the circles. It should not interfere and go inside these circles. It should not go inside these circles. But at the first point, wherever it is touching, you have to draw a smooth curve passing through all the points. Similarly, on this side also I have drawn this curve, smooth curve, just touching all these circles. So this purple color, whatever is there, this is the actual cam profile now. Now only this curve you have to make dark. Only this cam profile, whatever you have got, you have to make dark with the pencil. So you make this base circle also dark. So this is the actual cam profile. This is actual cam profile. All other lines other than this, whatever are there, they are all just construction lines. So even if you keep them thin also, it is fine. Now here it ends, the cam profile ends. Further, if you want, you can also draw a curve, just a dotted curve, what is passing through the center of all these circles, which we call it as pitch curve. This is optional. Only if you draw the cam profile also, it is more than sufficient. And the curve which is passing through the center of all these roller circles, we call it as a pitch curve. Okay, so this is the profile we have drawn for roller follower. Thank you.